Hello students, once more welcome to our classes, and today we will discuss another application of derivative approximations. This is very important topic, and this is the where it will help you in your higher classes, competitives, and this is very easy to solve. How we will use the derivative in approximations. The approximations, what do you mean by approximations? Here we know to derivate the square root of a number. Suppose the question is asking square root of 17. We have to do the long division method. Also the same time we can find this square root of 17 by this derivative method. That is called the approximation. Not only the derivative, just for example, suppose you know the derivative square root of 17 by division method, but are you able to find that cube root of 17? Are you able to find cube root of 28? So these will teach us how using differential, how using derivative to find the value of these functions, these values. Not only here, many complicated problems will come. Those problems also can be solved by this approximation. Before reaching to this approximation, some basic geometrical concept I want to say, which one we discussed already in the derivative. And today here in this question, just see this graph. Here if there is a point x, then this curve, this is a y is equal to f of x curve, then definitely this coordinate of this point will be your x comma f of x, because this is the y value is your f of x. If there is a slightly change as you are going right side of x axis, then in that case this will be the addition, right, and this will be x plus del x, some change is there. In that case what will happen, this coordinate of this point is your x plus del x comma f of x plus del x, right? And in this case you know that f of, if you will draw the graph value, here f of x, here f of x plus del x, what are you finding? When there is a slight change in x values, there is a change in y values. This rate of change of this x with respect to y, if you are doing, or y with respect to x, if y with respect to x, then we call it as derivative dy by dx. The differential of x is nothing dx, that is nothing your del x. Differential of y is nothing dy is del y. This del y you will get f of, how you will get f of this del y will give you del y is equal to that f of x plus del x minus f of x. And we know that this differential dy is nothing del y, and this del y, how you will get it? We know that this can be find out by, suppose y is equal to f of x, then if you will do the differential of this is your dy and is equal to f dash x into dx. This part you are writing, and since this dy is nothing your del y and this is f dash x into del x, means to get this del y we require to, sorry, it is del x, so you require to find f dash x into del x. And this value is the del y, the change. This is nothing your change, the change in x giving the value of functional change. The functional change is del y. And similarly, to get from this equation, if you have to write f of x plus del x, f of x plus del x will give you f of x will be transposed to that side plus del y. Replace this del y value here, then what are you getting? You are getting this is f of x plus del x is equal to f of x plus this is f dash x into del x. So this is your giving, this is the concept by which will solve your approximation problem. I hope everybody got it. So this will give you the approximation problem. I'll solve. Before solving, let us first understand how we will apply, what is the working rule to solve the approximation. Here the step 1, you have to define a function f of x, and second, decide what is x, what is del x, and then you find your f dash x. Then del y, as this del y is equal to f dash x and del x, then find this f dash x into del x is either dy or del y. But del y we know, del y you are getting f of x plus del x minus f of x. So this del y is f of x plus del x minus f of x. Transposing to that side, your f of x plus del x is equal to f of x plus del x. And this f of x plus del x will give you f of x plus f dash x into del x. So this is the basic concept of your approximation. So make a note in your notebook this thing, and that will help you. And you have to remember that del y is equal to f dash x into del x, and f of x plus del x is equal to f of x plus f dash x into del x. So using this, let us solve one few examples how we will use the derivative in approximation. Now see one example. The question is, find the value of root 25 by 3 using differential. Root 25.3 using differential. This is the question, how to do, how to find. Okay, as I told, define f of x. We have to define the function of x. Then you have to decide the value of x and del x. So here this is root of 20.5.3 is there. So in this case, so you define solution. Let f of x is equal to root x. So this is the definition of the function. According to the given value what you have to find, you have to define the function. Second thing, decide the value of x and del x. Here x means what? Here in this square root, what is its nearest value, whose square root you can find it easily, or it is a perfect square number. Which one? The 25. 25 square root is 5, you know. So it can be find as 5. So let x is equal to 25 and del x, the extra part, whether it is addition part or subtraction part, then accordingly you can take as the del x. Del x is 0.3. Now x you have got, del x you have got. Now we have to, next step is find f dash x. So f dash x is equals to, that is how much, d by dx of root x, that is equal to 1 upon 2 root x. This is your f dash x. Now next you have to find your, so del y, or therefore del y is equal to your del x into f dash x. So del x value you have got 0.3, f dash x 1 by 2 root x, that is 0.3 into 1 by 2 into root over of 25. This x value is 25 here. So that is 0.3 into 1 by 2 into 5, that is 0.3 upon 10, which is 0.03. This is the value of del y you have got, but we require to find, but we know that, but del y is equal to f of x plus del x minus f of x. So this implies the f of x plus, because this is required, f of x plus del x is equals to f of x plus del y. Now put the values of x plus del x, that is nothing, root over of 25.3, because this is your x plus del x, x is 525, del x is 0.3. Then f of x is root 25 and plus del y is 0.03. 0.03. So this implies root over of 25.3 is 5.03. This is your approximate value. This is your approximate value of this function. I hope you got it. So this way we will solve the problems of the approximation. So let us solve, just note it down, and let us solve more number of problems of this approximation. Now another example, example 2. Here another question is, find the 26 to the power 1 by 3 using differential. Right, in same method let us define function. Step 1. So f of x is equal to x to the power 1 by 3, because it is 26 to the power 1 by 3 is asking. According to the pattern, f of x is x to the power 1 by 3 you have defined. Now you have to define what is x, what is del x. Here 26, what is the nearest value of 26 whose cube root will exist? That you know, that is 27. 27 is greater than 26. So means minus 1, if it will be there from 27, then this will give you the 26. So x you define 26, del x is equals to minus 1. If you are able to define these three things, then you can easily get the answer. Now your second step over, third step, f dash x, derivative x to the power 1 by 3, that is you are getting 1 by 3 x to the power minus 2 by 3. As we know, del y is equal to del x into f dash x. So this will give you minus 1 into 1 by 3 x to the power minus 2 by 3. X value replace 27, that will be equal to 1 by minus 1 by 3, 3 to the power minus 2, means if it will be minus 1 by 27. This is your del y you have got. Then what will be your therefore? So f of x plus del x is equal to how much? F of x plus del y. So this implies this f of x plus del x means it is 26 to the power 1 by 3. F of x means it is 27 to the power 1 by 3 plus del y means minus 1 by 27. So this is you are getting cube root of 27 is 3 minus 1 by 27. Then what you are getting? It is LCM is 27 and it is 81 minus 1, 80 by 27. And you do the division, and this value, approximate value you will get nearest to 3-4 digit. So this is 2.9629. This is the approximate value of this cube root of 26. I hope you understood, and this is the answer. This is nothing is there, it is very easy, and in this way you can solve as many as question, and this is the concept, and this is your concept about the approximation. And in next video we will solve more number of problems based on approximation. So for today this is much, and thank you students.